All right, trying again without getting interrupted this time. Hopefully you guys enjoyed your day off yesterday with no Zoom call or Google Meet. Take a minute and copy that down. This is not meant to be there in the given information. Pause me. Okay, so let me show you how I found that. Hopefully you can recognize that this, oops, haha, forgot to write something down. That should be squared. This is in standard form with the H and the K. No, I keep saying standard form. It's called vertex form. The H and the K are 0. So y minus 0 squared and x minus 0 over here. So the H and the K are 0. That's how I got that. In fact, let me label that H, K. Hopefully you remember that from last time. It's probably a good idea to have those notes from last time out. Also from last time, that quantity, that negative 16, represents the 4a. So if 4a is equal to negative 16, divide both sides by 4. I get a equals negative 4. The fact that, the fact that it's negative tells me about the direction that it opens. So we're going to look at the fact that the y is being squared, along with the fact that the a is negative, and we're going to determine that it opens left. So a couple things. We remember what y equals x squared looks like, for sure. Y equals x squared opens up or down. Therefore, if y is being squared instead of x, then it opens left or right. When the a is negative, we choose the left direction, the negative direction, which is left. So right would be the positive direction, left would be the negative direction. If x were being squared, up is positive, down is negative. Okay? So a equals negative 4 tells me that the parabola opens left. So I can plot my vertex. The 4, let me grab another color. I didn't grab enough colors. The 4 tells me the focal length. The actual number part of it tells me the focal length. So the focal length is the distance from the vertex to the focus. You might want to write that down again. We wrote it down last time, but you might want to write it down again. If you do, pause me. The focal length is the distance from the vertex to the focus. Remember, the focus is always inside of the parabola. So if this opens to the left and the vertex is right here, then the focus is going to be in here, inside of the parabola. So the focus, let's label these also. This is the vertex. That's the focus. The focus is over negative 4 up 0. And then the last thing I need to do, one more thing. I think I need another color. Not doing a very good job with realizing how many colors I'm going to need on this. Okay, the directrix, so let me indicate that this is 4 units. The directrix is also 4 units, but it's on the other side. And it is a line that is perpendicular to the axis of symmetry. So if I open to the left, my axis of symmetry is this, right? So perpendicular is going to be like that. So the directrix is going to be the line. See if you can write the equation of that line real fast. X equals 4. It crosses the x-axis. Every single point on that line has an x value of 4. Okay, the last thing we need to do is find what's called the lattice rectum. So go ahead and take a second to laugh at that. Haha, I said rectum. Okay, let's get over that now. The points that are on the lattice rectum, or LR as I like to call it, line up with the focus. You might want to write that down also. The points of the lattice rectum line up with the focus. Okay, LR. If they line up with the focus, that means they're going to have the same x value, right? So all of these points have different y values along this line, but they all line up with x equals negative 4. So to find the LR, I know that x has to equal negative 4 because they're going to line up with the focus. So think of the parabola opening this way. I'm trying to find these 2 points that line up with the focus. so that I can actually graph the parabola. Okay, these 2 points have different y values. This one has a negative y value and this one has a positive y value, but they all line up with x equals -4 lined up with the focus. So I'm going to take that and plug it into my equation. And it should always work out nicely like this. It's kind of what happens with the LR, where you get a perfect square, and when you take the square root of both sides, you get plus or minus 8. So it looks like I'm going to have to label my axes. I did not think ahead. So I'm going to say that for the x-axis, this is 1, but for the y-axis, this is 2. So that this would then be 8 and -8. So then I can plot the points of my LR. I plugged in -4 and I got out positive 8. I also plugged in -4 and got out -8. So -4, comma 8 and -4, comma -8. And now I can graph my parabola. Good. Okay. Let's see if we can do it with one that's a little bit more complicated. Not much. All the same info. This should probably just really be B instead of a whole nother example, but whatever. All right, let's see if I can fit this in here. Okay, this is not in vertex form, so we need to get it into vertex form. And the way that we do that is by completing the square. So the first step for completing the square is to separate the variables. So y is on one side, x is on the other side. You might want to write these steps down, pause me, write them down. I'm going to try and keep this video short if I can, because I know you're going to be doing a lot of pausing. Completing the square, we take the coefficient of the linear term, the y, or if it's a x squared, it would be the x, the b. So remember, ax squared plus bx plus c is for anything of degree 2. So we're going to take that number, we're going to divide it by 2, and then square it. So we're going to do the parentheses first, -2 squared. We got to add that to both sides. And just indicate that we're adding it to both sides. The whole purpose of that, remember, you've talked about completing the square several times before. The whole purpose of that is this thing should factor to a perfect square. What multiplies to 4 and adds to -4? Right? So you may not need this step right here. I'll finish the right side in a second. You can probably jump straight to this. Okay? That's the whole point. If this doesn't factor to something that's being squared, then you didn't complete